So we can start.
Okay. Good afternoon to you all, and welcome to my talk on human impact on modifications of the biogeochemical processes in the seas around India. Mainly, I would like to focus in this talk on how human discharges or human related activities, either directly or indirectly, how it is impacting the biogeochemical processes in the northern Indian Ocean, mainly Arabian Sea and the Bay of Bengal. And there are several international allegations on over-emphasizing the human impact, mainly from the India. And these emphases have gone even beyond to the international waters. And the allegations have come in such a way that the discharges from the India even modifying the biodiversity beyond the national jurisdiction. Unfortunately, most of these allegations have no scientific base. They mainly based on the kind of we are utilizing high amount of the fertilizers, or we have a lot of pollution over our subcontinent, and the depositions may be changing the seas around India. So it is a high time for us to look at whether those hypotheses made by those communities, whether we should agree it, or with the pure scientific base, we need to disprove it if it is not. So I basically work on the biogeochemical processes in the northern Indian Ocean, where mainly I look at using the chemical tracers or even the isotopic tracers to look at the how ecosystem is being functioning, or identifying the sources of these pollutants using these isotopes. In this study, actually, I could able to look at these allegations and try to give some answers for those allegations, either to accept or reject. So this talk actually mainly focuses on this kind of studies what have been carried out for the past couple of years. So I will show you my presentation now. I hope you could all see my presentation.
Yes, you are visible. Please go ahead.
The title is on the human impact on the modification of biogeochemical processes in the seas around India. The coastal regions especially, they are actually quite sensitive because this is much more serious to the Indian Ocean side, because there are a lot of population in the Asia and Southeast Asia regions. There are a lot of pressure to the coastal region through the human-made discharges of the effluents. And these processes actually making it has a very unique and large spatial variability of the coastal processes naturally being happening, such as upwelling or the mixing, even the orography. All these issues actually brings the different kinds of the elements into the surface waters, and that makes very difficult to separate those from that of the anthropogenically injected chemicals. Now the human impact actually on the coastal regions, especially from the Asia and especially from the India, has been overemphasized, and due to the mainly lack of the data or even the understanding. And it is high time either we should accept these hypotheses or we should prove it using the several sophisticated chemical and biological tools are available now to disprove or the prove that these hypothesis made by the international community is acceptable or not. Now, compared to the elsewhere in the world, we need to bother more for the human impact on the northern Indian Ocean. If we plot the human population with reference to the longitude and the latitude, what you would see is that the maximum amount of the population actually dwelling in the northern Indian Ocean surrounding areas. So therefore, one would expect more amount of the anthropogenic pressure in this region, and therefore when you want to study a biogeochemical cycling in this region, we just cannot avoid the human impact, at least to some extent. The second important one, which entire world knows, is that the air pollution is much more over the Indian subcontinent and also over the Chinese. See, these two regions, you see that aerosol optical depth is quite dark, red in color, where you have a lot of air pollution, mostly actually the secondary aerosols, and mainly the anthropogenic aerosols are much more over this region, mainly the Indo-Gangetic plain and so on. So we have the more pollution is coming from the atmosphere, and maybe the more from the land side. The third important one is that we are the second largest fertilizer consuming country in the world. The first one is China in terms of the nitrogen or in terms of the phosphate, the second largest in the world. So people assume that this the excess fertilizers which are using on the agricultural lands may be ending up into the rivers and from the rivers into the ocean, and therefore contaminating the coastal waters and therefore the international waters from there. So these are the fertilizer exported by the rivers. They are all coming from the models. What they said is that in the 1990s, the scenario on the top, and in 2050, this is going to be increased by 2 to 3 folds from the top what was in the 1990s. This is based on the models, not by the observations. So based on all these issues, what they thought was that the rivers transporting the nutrients, mainly the nitrogen, which is increases even in the future at a much larger scale in the Asia compared to the other parts of the world, like in North America, the Europe, and Africa, and so on. So therefore, the coastal systems are suggested to be under the threat, and this kind of the fertilizer washings may lead to the high biological productivity or the eutrophication or maybe the oxygen deficient layers to form and would change even the ecosystems and so on. So this kind of assumptions or hypotheses have been made based on this kind of a modeling efforts done by the different communities. There is a fallacy in the international legations based on this high fertilizer utilization, what I have shown before, and the discharges of the sewage or the effluents, we have a lot of rivers and which are bringing the land-based pollutants maybe to the coastal regions, and we have the high atmospheric pollutants. All these issues made people to make kind of an hypothesis that these waste discharges into the coastal waters leading to formation of the dead zones and shift in the ecosystems, and even biodiversity beyond the national jurisdiction seems to be changing. But make a note that all these were made without having any strong scientific base. And many of these issues even discussed even in the parliament at sometimes, that to look at the possible answers with the scientific evidences. Now, I may not able to explain all those issues within the 1 hour time, but I try to put up the few of the international allegations we have on the Indian subcontinent. The first one actually, there was a report issued by the United Nations on 11th July 2017. This panel, they highlighted that there is a threat facing the Bay of Bengal due to release of the fertilizers and pollutant of the Bay of Bengal, causing significant threat to biodiversity. And they actually called for an urgent action in introducing immediate legal protection to the world's ocean and high seas. And this was actually framed a legal framework under the biodiversity beyond the national jurisdiction. In the MOES laboratories, I think CMLRG was responsible and representing from the Indian side for the BBNJ committee to work on that. Now, This issue, even though they said the country is surrounded by the Bay of Bengal, since India is sharing more than half of the coastline of the Bay of Bengal, therefore the major blame goes to the Indian subcontinent. So we need to look at whether we are really releasing this kind of anthropogenic nutrient into the international waters, or really we are responsible to change in the biodiversity beyond the national jurisdiction. Now, we know that India has a thick network of the rivers on the entire Indian subcontinent. And we also know that most of the major rivers actually they originated on the western India, but actually they opens up into the Bay of Bengal, like a Godavari or Krishna or Mahanadi. So most of the major rivers are actually taking life in the west and bringing all those polluted whatever released into the rivers into the coastal waters. Now this is the fertilizer consumption in India. So most of the states through which the rivers are flowing into the Bay of Bengal are actually consuming about the 75%, whereas the west coast, which is receiving very small amount of the fresh water, so those states are utilizing even less than 25% of the total Indian consumption of the fertilizers. So one would expect that if all the excess fertilizers from the agricultural land is ending up in the rivers and are being brought into the coastal waters, one would expect that the coastal Bay of Bengal may be heavily polluted with the fertilizer nutrients, and therefore many harmful algal blooms may be forming, or even the thick oxygen minimum zones maybe, or the dead zones may be forming along the east coast of India. But the reality is that there are no such reports of the formation of the any dead zones or formation of any harmful algal blooms along the east coast of India. Rather, they are forming in the along the west coast of India, like in off Kerala, where we would see during the southwest monsoon the red noctiluca blooms occurs, even off Bombay or even into the open ocean region, where the green noctiluca forms during the winter time, where river discharges are much more less compared to that of what you would see in the east coast. Now, if our rivers are heavily polluted with reference to the this nitrogen pollutants, I'm just comparing here what is the scenario in the developed nations, like in Europe. I'm just taking an example of the shelled estuary, which is supposed to be highly polluted, where you see the dissolved inorganic nitrogen is quite high, is about 300 micromoles per liter, and throughout the year, on average, you will see 150 to 200 micromoles of the dissolved inorganic nitrogen you have. Even if you look at in the California estuary in USA, where you will always see more or less something like about the 50 micromoles of the nitrogen throughout the year. And in the China, it seems that it is more increasing in the recent years, and is going to the almost 100 micromolar throughout the year. Now we see the Godavari estuary, which is the largest monsoonal estuary on the Indian subcontinent, where we do get up to 80 micromoles of the nitrate only for a period of 1 month or 1.5 months. This data is generated for collecting the samples every day for about the 5 years, and this is the mean of that. So remaining time, the concentrations are very low, because you all know that the discharge of the fresh water in India is heavily controlled by one by monsoon, the second one by the dams. So therefore, we have a pulse of discharge occurs only for a month of 2 to 3 months during the monsoon time. The remaining time, our estuaries are filled with seawater mostly. So therefore, our estuaries are releasing some significant amount of the inorganic nitrogen only for a period of short while, for a period of a month or two, but remaining time much lower than compared to that of the global estuaries from the developed nations. Then we started collecting the nitrogen and nutrients data from the about the 30 rivers all along the Indian subcontinent. Then came up with a budget of 0.22 trillion grams of the dissolved inorganic nitrogen seems to be fluxing into the Bay of Bengal, which is 10 times lower to the Arabian Sea, because where the discharge is much, much small. What we further noticed is that about the 96% of the riverine nutrients, they are either removed through the geochemically or utilized biologically uh, into the sediments, and very small amount is being fluxed into the coastal waters. Never ever reported the eutrophication nor the formation of the dead zones of these river mouths along the east coast of India. Now, whatever has been fluxed into the coastal waters, to what extent they are actually being spread into the open ocean region. So to do that, we try to measure the nitrogen isotopic values of the particulate nitrogen, because if you release the dissolved inorganic nitrogen, that will be fixed by the organic matter, by the phytoplankton, that will reflect in their body. So based on that, at different river mouths and also the cities, we have done the isotopic values from the coast to the offshore regions. From that, this is the example I am showing at the off Visakhapatnam, where the more sewage impact is more than the riverine impact, where we could see that the 15 to at the most along the east coast, 36 kilometers from the coast, the impact of the anthropogenic nitrogen can be seen from the coast to the offshore, but definitely not beyond that. So, in addition to that, we try to measure the nitrogen isotopic values of the nitrate in the open ocean regions, which is actually showing between 4.9 to 5.5 per mil, which is the typical marine signals, not so much impact on the, not a significant impact from the anthropogenic signals. So this showing that there are no indications or the negligible contribution of the anthropogenic nitrogen inputs to the open shore regions, and therefore the change in biodiversity beyond the national jurisdiction is not caused by the inputs of the anthropogenic nutrients to the international waters. Then we know that we are using the very high amount of the fertilizers in India. We are the second nation after China in utilizing that. But we could also see that there's a high amount of the nutrients are being found in the estuaries during the monsoon time. So, do you think this may be impacting the the biodiversity in the estuaries? The second one is that even though other regions are utilizing much less fertilizers, but they have the very high amount of the nitrogen is being fluxed through their estuaries. So what is happening to the uh, other excess fertilizers, which is not being seen in the rivers? So that means where do these excess fertilizers are going? These two are the questions actually coming to our mind. Now we have seen the isotopic values of the nitrogen in the all these estuaries, about the 30 estuaries which we sampled. We could see that much of the northern estuaries in the northern India, that is where the more fertilizers are being used, where you could see the lighter isotopic values in those estuaries. And whereas in the southern side, like in Tamil Nadu or the Kerala and even Goa and Karnataka, where the much less amount of the fertilizers are being used relatively in the coastal zones, where the very heavy isotopic values have been seen. So that shows that in the northern estuaries, where the more the fertilizers have been polluted in the estuarine waters, we could see that even the diversity of the phytoplankton in the northern side, the diversity is very less. We have the more dominance, we have the more of the bacillorhizia dominated in the northern estuaries, whereas while very good diversity we could see in the southern estuaries. So therefore, these fertilizer release, whatever amount it may be into the rivers or into the estuaries, they have an impact on the biodiversity in the estuarine regions, which is actually within our continent. Right. Now, what is happening to the excess fertilizers which are not being seen in the rivers. Actually, they are actually contaminating our groundwaters. So these are the groundwater data which we collected along the Indian coast. About the 100 samples we have collected all along the Indian coast. What we have seen is that most of the zones, their concentrations actually during the wet period is quite high. And this is not only our data from the west, in the coastal region, even the central groundwater board also collected from the mainland of India and most of the regions. The dissolved inorganic nitrogen is above 45 milligrams beyond the drinkable level. So based on the fertilization in those regions and the soil nitrogen, the phosphorus concentrations and their relationship with the groundwater concentrations and isotopic composition of the nitrogen and ammonium, we came up with a significant fraction of this nitrogen in the groundwater is coming from the anthropogenic sources. Then this nitrogen or the phosphorus can be exchanged to the coastal waters through the submarine groundwater discharge. So based on the submarine groundwater discharge rates already available from the some zones along the east coast, from the east coast and the west coast, we try to compute that about 1.9 to 1.38 trillion grams of the DIN, dissolved inorganic nitrogen, dissolved inorganic phosphorus, can be fluxed to the coastal waters from the submarine groundwater discharge, which is almost close to that of the riverine fluxes to the Indian coast, to the entire Indian coast. This may have significant impact on the coastal ecosystem. We did some experiments by mixing the river waters, so coastal waters with the groundwater. We could see the blooming of the coastal waters, and also we could see there is a change in the diversity of the phytoplankton. But these are not enough to conclude that the significant impact can be seen because of the STG alone. But definitely there are some impacts. Like we could see in certain zones where we have the blooms of the phytoplankton, but not to the extent they are going to the harmful algal blooms, but where the nutrient supply cannot be explained by the physical processes. There may be chances that the STD may be contributing to the coastal waters. Nevertheless, at this stage, we are not in the state to say that the SDG has a significant impact on the coastal diversity, but still we need to. This is one of the gray area where we need to look at, but it may not be insignificant. The second allegation is that this mainly came on the Bombay region. They said that the untreated sewage, even though they said the Indian subcontinent, but mainly from the Bombay High region, it is changing the ecosystem in the Bay of Bengal and leading to shift in the ecosystem from the diatoms to the dinoflagellates. This is the reason to have even the hypoxic conditions even close to the surface because of the sewage organic matter is getting decomposed in the seawater, leading to formation of the hypoxic conditions even close to the surface. Those conditions are favoring noctiluca to bloom in this zone. This has a significant impact on the damage to the fishery resources. This has been published in the Nature Communications in 2014 and mainly focusing on the sewage, untreated sewage from the Indian subcontinent. Then we have gone to the same region, try to sample it, whether we have a signals of the coast, the sewage organic matter or the sewage nitrogen. We could see here is that the isotopic composition of the carbon, which is varied between -22 to -23, which is a very typical marine signals. We don't see any typical the sewage signal. We also sampled even the coastal the sewage samples from the Bombay and Gujarat regions, which are far from that of what you have seen in the marine regions. Similarly, in the bloom regions, even the nitrogen signals are very close to that of the marine signals. Where the non-bloom region, where we have the intensive mixing, where we could see the very heavier isotopic values just because below that we have the denitrification zone. where the nitrogen isotopic value can go beyond even the 20 per mil. Because of such waters are coming to the surface, so we see the heavier isotopic values here, but not in the bloom region. So we could clearly say that the blooms are occurring not because of the anthropogenic inputs, it's the in situ process. Then we try to explain that why it is happening is that these blooms are not actually occurring in the recent years. They are being seen since the past several decades. There are several reports in the literature to show that that really happens the middle of the February to the beginning of the March. This is the time always these blooms occurs. Then when the West India coastal currents actually take the return flow, actually they spread into the open sea region that leads to the formation of the stratification, which arrests which even decreases the vertical convective mixing. Because since the silicate line actually exists much deeper beyond the 100 meters, when the vertical mixing actually shallows, the silicate supply will be stopped. Once you don't have the silicate, diatoms cannot able to bloom. So when you have this is the phase one, when you have the adequate nitrogen, the phosphate, we have the low silicate, first actually diatom starts bloom. When the silicate is going down, we still have that still nitrogen and phosphorus that can still come from because they have the shallow nitrocline and the phosphocline. That is the time this heterotrophic noctiluca starts blooming. And when the diatoms actually they feed on the diatoms, when the diatom population goes down, they start blooming. This is the simple natural phenomena which is being occurring, but actually they reported that this may be due to the pollutants released by the Indian subcontinent, which is not really true. Then there is a third allegation is mainly coming from the Bay of Bengal side, where the
Patmakar, I think we lost him.
Yes, sir.
Okay, so we will wait. Don't worry. Okay.
They keep loading the
Yeah, please load the PPT and reach the place where you were.
yeah.
And you can start now, sir.
Okay. Yeah. So there is a measurements were done actually using the high resolution oxygen profiles in the Bay of Bengal to the even the nanomolar level, and they found that there are some layers where the oxygen concentrations are so low. Any addition of the nitrogen input, either from the atmosphere or from the rivers, would make these zones as a dead zones. Then we try to visit this. Actually, this kind of a allegation was made based on one-time observation in the Bay of Bengal, and we try to violate the data from the 1970s to the present, whatever the data we have, and we try to look at that what the variability we have in the oxygen minimum. In the Bay of Bengal, there are lots of eddies. You see here on the top right side, these are the SSHA anomalies, sea surface height anomalies. The red in color, which is actually the anticyclonic eddies, and the blue, where the cyclonic eddies are there. Actually, I represented here as the ACE and C here. So always you see, throughout the year, you will find this kind of eddies in the bay. The anticyclonic eddies where uh, the, the the convergence actually takes place, where the oxygen actually ventilates into the oxygen minimum zone. So we have shown you the profile here in the middle, where this is the temperature, which is the blue in color, the ACE, which is much warmer compared to the no eddy zone NE, and the red one is the C, cyclonic eddy zone. So even the oxygen you see here, that more oxygen is you have under the anticyclonic eddy, even in the oxygen minimum zone. So therefore, the anticyclonic eddies are ventilating oxygen into the deeper waters, and therefore they are actually there no chance for this oxygen minimum zones to become a dead zones. Then we have gone to the same zone where the Bristow actually reported that these are the zones where the oxygen concentrations are very low, where when you actually occupy several times, even in the recent and also in the past, only certain times we have the low oxygen, certain times we have the very high oxygen. Because under the cyclonic eddy, where the more primary production occurs in the surface, where the more export actually taking place to the subsurface waters, where the oxygen minimum zone temporarily may become intensified, but within a few days or weeks or even in the months, they will be oxidized by the anticyclonic eddies. Therefore, the formation of the low oxygen zones in the Bay of Bengal is a temporary phenomena. It is not a permanent feature, and it is not caused by the anthropogenic inputs. It's just a general, the natural phenomena by the cyclonic and anticyclonic eddies. You could able to explain this kind of a variability. Now the fourth one, which is a more serious one, is the atmospheric dust over the bay is much higher than elsewhere in the world. There was a report in 2000 where they measured the trends of atmospheric aerosols by in terms of the AOD, like aerosol optical depth. They actually done between the 2000 to the 2009. They found that the increasing trend was the highest over the Bay of Bengal, which is the 0.076, and the second one comes to the coastal China, which is 0.069. So that they said that over the Bay of Bengal, the atmospheric dust is so high, which is also driven by the anthropogenic aerosols, which is the red in color you see in the second one, and therefore its deposition and may be having a significant impact on the biogeochemistry of the Bay of Bengal. We try to estimate this trend even the recent years between the 2007 to the 2017. What we see it is much more than that of it before. It was actually 0.076 per decade. It is a 0.01 per year. That means 0.1 per decade now. So that means the aerosol optical depth is increasing even in the recent years, and they contain significant depth of sulfates and the nitrates. The increase of the nitrates may enhance the primary production, but whereas the nitrate and sulfates also form sulfuric acid or the nitric acid, and their deposition will have an impact on the acidification of the surface waters of the bay. Now, we try to compare a older data set that was collected from our group in 1991 at the coastal Bay of Bengal, and in 2011, after 20 years, during the same period, the same region, what we have seen was that in 1991, this region having the high pH and low CO2, even the much less than the atmospheric CO2 level, and it was acting as a sink for atmospheric CO2. And the same one in 2011, it is actually acting as a source to the atmospheric CO2. So because of the acidification of these waters. Based on this, we actually computed that the rate of acidification as a 0.007, which is actually 0.0017 or to 19 elsewhere in the world, like a 3 to 4 times higher rate of acidification is taking place in the Bay of Bengal than that of the elsewhere in the world because of the deposition of the atmospheric CO2. This is just based on the two data sets comparison. Then we have a much longer data set, and which is actually spanning for about the 12 years, 12 to 13 years. From the 2007, we started measuring at the every month. What we have seen was that there is a strong salinification. The salinity was actually increasing in the coastal waters, and there is a warming up, and the pH is decreasing at 0.007 in the very close to the coast, 0.004 in the offshore region. The rate of increase of the PCO2 is much more than that of the what we see in the pristine zones. I mean, pristine zone only the atmospheric CO2 increase at the global level, where the 2 micromole at the most ppmv is increasing per year. Whereas here, close to the coast, we have 10 microatmospheres, and the offshore region about the 6 microatmosphere. At this rate, actually, the CO2 is increasing because of the deposition of the atmospheric pollutants. On the other hand, high nutrient input also we will see in terms of the nitrogen and the phosphorus, and as well as the iron also, which is a much more actually on the bay, because of the bay is receiving more of the anthropogenic aerosols, whereas the Arabian Sea actually receives more of the natural aerosols. So it shows that on average, actually it is contributing to the about the 13% of the primary production because of the addition of the atmospheric nitrogen. Whereas in the close to the coast, in certain periods, it can actually contribute up to the 33% of the surface production by the atmospheric deposition. Now, what is more important here is that the nitrogen deposition is much more than the phosphorus deposition. You see here the nitrogen in the micromolar scale and the phosphorus in the nanomolar. It is changing the N2P ratio of the surface waters. That has an impact on the biodiversity, because if the higher the NTP ratio, we have the different groups of the phytoplankton will proliferate than at the lower NTP ratios. We did several laboratory experiments by addition of the atmospheric dust into the coastal waters, even the open sea waters. We could see significant shift in the phytoplankton composition. So therefore, atmospheric deposition is modifying the diversity of the plankton and also acidifying the coast surface waters. So and therefore it is reacting as a more of the source of the CO2 to the atmosphere than that of the sink in the past. In addition to that, ocean acidification is also expected to modify the plankton composition. There are lots of experiments they have done even in India, even elsewhere in the world, and it changes the certain groups of the plankton could able to take the advantage of the ocean acidification. There are certain amounts, certain other groups cannot able to survive at that change in the pH. In addition to that, we have seen that in the coastal waters, nitrogen is increasing, even phosphorus is also increasing at but a much lower rate, but the silicate was actually decreasing, which is in association with the increase of the salinity. Because river discharges are relatively actually being decreasing in the recent years for the past few decades, and the silicate is the sole source. Rivers are the sole source of the silicate to the ocean. If the silicate is decreasing and the N and P is increasing, there may be a possibility of the shift of the phytoplankton from the bacillophyceae to the dinophyceae or the cyanophyceae. That also we could able to see that the phycoxanthin, which actually represents the diatoms, which is actually decreasing in the coastal water, their population, their abundance, the biomass, where the zeaxanthin as well as the dinoflagellates, they were increasing. But at the present state, they are not at the stage that the complete shift has been taken place, other significant. But we could see the signs of this shift in the ecosystem from the dinoflagellate to the from the diatoms to the dinoflagellates due to this deposition of this nitrogen nutrients. Now the models are showing that this kind of this was the present the pre-industrial scenario of the nitrogen depositions on the top. The middle one is the 2000, and in 2030, one is expecting that the 10 to 100% of the nitrogen deposition from the atmosphere is close to that of what is coming through the mixing of the deep waters. At present, nitrogen deposit from the atmosphere is actually contributing to the 10 to 30% of the deep water nitrogen coming to the surface, which may go up to the 100% in the future. This is what the models are actually projecting for the future. Nevertheless, what we understand so far is that there is some impact on the anthropogenic into the coastal regions. We need to identify the source, not just a concentration. Unless we put that into that, this kind of allegations when they're coming from the elsewhere, we cannot able to answer to that. Now to do that, not alone measurements are enough. We need a more process-oriented models. Let us see that how models are doing well in our regions, either the regional models or the global models. This is the model which is actually showing that simulated nutrients, actually high nutrients are coming from the rivers. This is actually coming from the trends actually shown by MP and ESM MR histological simulations. What they've shown here is that the more of the phosphate is coming from the model or from the rivers into the Bay of Bengal. Actually, not much phosphate can come from the river because phosphate has a association with the particles, mineral particles coming from the rivers. They actually adsorb on it and will be removed, which is the well-known phenomena. And whereas the river should bring actually more of the silicate, but actually the models are not showing silicate. I understand this many of these models, the discharge, real-time discharge is not the parameter. And they don't have the concentrations of the nutrients in the many of the rivers are actually not part of the models, and therefore so they are not able to represent really what is happening in the real time, what kind of nutrients are coming from the rivers into the open ocean zones. Not only the regional models, even the IPCC models are failed to reproduce the CO2 fluxes in the Indian Ocean, especially in the northern Indian Ocean. Actually, this was an opportunity I had way back in 2012 to look at how IPCC models in the Indian Ocean is performing with reference to the observations we have. What we have seen is that in the top panel, where the cumulative CO2 fluxes is the dashed lines coming from the observations, all the models are seems to be underestimating, especially in the northern Indian Ocean. They are not even reproducing even the seasonality in this zone. The mainly either the vertical mixing is weaker because we have the monsoon system, we have the different mixing patterns, and also even the land-based inputs through the rivers or from the atmosphere, they are not actually part of these models because for the global model, this region is much smaller. So therefore, they are projecting that these zones are absorbing more CO2 than that of what they are doing. So now we are re-evaluating actually this year the improvements of these IPCC models, how best they are doing. I know that even the IATM this year they are also participating to the in this estimations by the IPCC of the CO2 fluxes. So we need to check it how best they have been improved from that of about more than half decade ago the scenario. The major problem comes here is many of the models is that typically these are NPDZ models. We have there's a lot of boxes in that, like the nitrate means we have the nitrogen, phosphorus, silicate, and the trace metals, and there is a different kinds of the planktons are coming. There's a lot of interactions among them, and most of these interactions and the time scales what we have derived mostly actually coming from the elsewhere in the world. So most of these the size of the detritus is being formed in this zone because we have a particle association coming from the rivers. Most of them is getting either the ballasting or maybe some of the nutrients are associating with the particles and being removed. This kind of reactions, this kind of an equations are not part of these models, many of them. And there's no information of the source of the nutrients in that. So really it is coming from the anthropogenic and coming from the natural, it is coming from the river or coming from the atmosphere. And we don't have the atmospheric nutrient depositions as a part of these models. So therefore, they may not be able to do pretty well than that of what we expected. Added to that, the climatology of the nutrients, say the basic for this any of the models is very poor in our zone. This is the kind of a climatology we have. The blue dots are actually showing the one-time observations in many of these regions. So there's a sparse, there's a lack of data availability of the climatology of the nutrients here. This has been extrapolated or interpolated to the region to get that. So therefore, now the data is available, we need to pull it because in the climatology of the world ocean climatologies, we don't have much of the data collected by the Indian scientists is not part of that, either due to EEZ problems or maybe some other issues. So this is the time to pull out all this data to prepare the good climatology. Whereas there no are the poor climatology for the phytoplankton or the bacteria or the zooplankton, this kind of climatology will never been made from this zone. So this kind of a poor background data our models are being run at this moment. So therefore, models are lack of atmospheric chemistry module where the atmospheric depositions are not major part of it. Maybe the some models may be having not the major models. Land ocean interaction to the river discharge is one of the very important, mainly from our zone, which is not seriously taken. Submarine groundwater discharge, as I mentioned to you, which is almost close to that of the river discharge, which is need to be worked a lot on this and how it is going to change the coastal ecosystem. And the ecosystem interactions must be derived from the Indian Ocean than taking from the somewhere else, because our zone is completely a unique zone. And without human dimension in the models, the reproduction of the or the future production projections of the changes is quite difficult, especially in the northern Indian Ocean. I thank you all the funding agencies actually to help me to do this kind of work, including CSIR and MOES, even the DST and ISRO, even the other laboratories like NCCR and the IPOIS. And this work was done under the international programs like SOLAS, Lloyds, and the Biogeochemical. Thank you very much.
Thank you, Dr. Sharma, for a very exciting talk that you could keep the crowd and so many informations and very fundamental informations, also challenging several threats by literature posed on us. Very interesting talk. So we have some questions from the audience.
Yeah.
So it's given to you through the chat option.
Yeah.
Please read the questions.
Okay. The question number 1: the fertilizers nitrogen and phosphorus are finally making their way to Indian coastal waters either via river runoff or via submarine discharge. Still, it is not causing the eutrophication. And why? Can you explain? Can you please enlighten this? That was the question actually asked by somebody. The answer is that it is true that the coastal waters are receiving N and P either through some extent from the rivers or from the submarine groundwater discharge. The reason why we are not getting the harmful algal blooms is that typically harmful algal blooms comes when the silicate is very low. When the silicate is high and the N and P is available, typically diatoms actually picks up. In case of the Bay of Bengal, rivers are also bringing significant amount of the silicate. If you look at in the coastal waters, throughout the year, the silicate is more than 2 micromolar, much more than required for the diatoms to grow. So we do see the phytoplankton blooms of diatoms, but not of the nuisance phytoplankton blooms like a harmful algal blooms. But if you stop the discharge, if you decrease the discharge, either by the dams or by the interconnecting rivers, whatever it may be, the silicate is going to be decreased. That is what you have seen. Actually, what I have shown is that the salinity is increasing and the silicate is being decreasing, but not to the extent at this moment to stop actually stopping the diatoms to grow. But if that occurs, then it may turn this Bay of Bengal also to the eutrophicated and the formation of the harmful algal blooms. Then the second question was that how can we separate the isotopic nature of DAN released through the estuaries and the submarine discharge? There are several ways, and there are some complications as well. First, we need to study what kind of isotopic signals we have in the estuaries and also the processes. In some regions, in the groundwater may be denitrified. So we have also measured these nitrogen isotopic traces in the groundwaters. So where the denitrified zones, nitrogen isotopic value will be very heavy. Those zones which are not denitrified, if it is contributed by the fertilizer or the anthropogenic one, there will be lighter isotopic values. So depending on this, the close to the groundwater isotopic signatures and the riverine signatures, we could able to separate and also to see the contribution of these two kinds of submarine groundwater as well as the river contribution of the nitrogen to the coastal waters. The third question was that what was the data source of the Nature Communication paper which published about Mumbai raw sewage mixing with coastal waters as you proved it wrong. It's interesting to know the data used in this paper. In this paper, the population data was generated by themselves, but they have taken the data from COMAPS data of the NCCR, the Coastal Ocean Monitoring and Prediction System data. Now they are calling it the seawater quality monitoring. But there was a mistake in the sense there was a flaw in that they have taken the average of the top 100 meters of the data. Certain zones, the mixed layer is much shallower than the 100 meters. Below the mixed layer, the oxygen will be low and the nutrients will be high. When you average it, entire this data set, you will get the very high concentrations in the surface of the nutrients, very low oxygen concentrations in the upper layer. That is where the flaw it is. The second one is that the COMAPS data is very close to the coast, either 5 kilometers or the maximum 10 kilometers from the coast. And that is where they are not reported the noctiluca blooms. They are actually reporting in the offshore regions where the discharge is being occurring or the sewage is being occurring where you don't have the noctiluca bloom, how it is happening in the offshore region. That itself is a flaw in this kind of an observation. The second one, they never proved that this kind of a sewage signals in the operation region just because sewage is being injected from the Bombay, which is a much bigger the city where the more sewage is being produced. They just hypothesis to do that, not because of by identifying the real source into that. That is what we have done in our study. The fourth question was that what is uptake rate of the DIN in groundwater? I understand the transport of the DIN in groundwater to the coastal waters may be longer than through the estuaries. Yes, there are two issues here. Groundwater discharge is occurring at the many places along the coast. The regions are more than the discharge. Discharge is also happening only 3 months time. The groundwater discharge is being happening continuously. Based on the rates estimated, we made an approximation. Actually, this approximation because the rates are not available for the entire coast. Now I know that NSS is trying to do much more significant way by measuring the exchange rates at many locations. We may have the much better picture. But the uptake rates, what we have done was in the coastal zone by mixing up the groundwater with the coastal waters, it came up to maximum up to the 0.2 micromolar of nitrogen per liter per day. That much of the uptake rates we have using the isotopic tracers. So this is quite significant. So there is a change in the diversity also we have seen by adding this. The question here is that we added like something 10% of that by assuming the 10% of the coastal nitrogen is contributed by the submarine groundwater discharge. So that's why these are the kind of a preliminary results because each zone the contribution of the groundwater discharge is variable. Like of Godavari, for instance, it is up to the 30%. It was actually directly measured by us, even by the PRL. Even the Gujarat region is quite high. And the Kakinada region of Andhra Pradesh is also quite high, but certain zones is quite small, like in the certain zones in the Tamil Nadu and so on. So therefore, we need to take into the consideration of how much it is contaminated in the coastal waters. Based on that, we need to conduct this kind of experiment. Finally, come up of how much of the groundwater discharge is affecting the coastal ecosystem. There is another one is that can we know the group of phytoplankton taking advantage due to the ocean acidification? I may not give you the complete answer because there are few I'm sorry, there are few experiments have been done by NIO. There they have shown that diatoms actually taking more advantage. Even the tintinnids, that is the zooplankton, they are also taking the more advantage in the Bay of Bengal as well as in the Arabian Sea. Only the few regions, few experiments have been done. There they have shown that these two guys are taking advantage and they are actually, the remaining guys were actually declining at the low pH waters. But I cannot conclude that from these few experiments that these are the only guys are being affected, because the ocean acidification impact is much more vast than that of what the experiments we have done it. This is another gray area where we need to work more on that, how the ecosystem change is expected to take place. With the limited data, what do we have, the 10 years of long data, what we could see is that there is some change in the plankton. And it is also not enough to conclude that, because we need to look at even the zooplankton data, the changes of the grazing impacts and so on. So therefore, this is still, I keep it as the gray area in our job. Thank you so much for the questions asked.
Yeah, thank you, Sarma. You answered the questions very well. And thank you for your valuable time to give a webinar in Modeis webinar series. Thank you very much.
Thank you so much.
We can go offline now.
Okay, thank you.